Dear students in first and second secondary classes, hello everyone. Welcome to my department of Sophomore High School. The objective of this tutorial is to solve graphical equations and inequations. Let's start by application number 1. The graph C to the right is that of the function f in an orthonormal system of axes. One, solve graphically the equation of x equal to 0. First of all, what is the graphical meaning of f of x equal to 0? As we said before, this equation determines the abscissas of the points of intersection between C and x prime or x. It is very clear that C and x prime or x are intersecting at 2 points, whose abscissas are minus radical 2 and radical 2. So the solution of f of x equal to 0 are x equal minus radical 2 or x equal to radical 2. We solve f of x greater than to 0. This inequality is well verified whenever c is above x prime or x. So to solve this inequality, we should specify the possible values of x for which c is above x prime or x. Look at the figure. I will color the region in which c is above x prime or x. It is very clear. In this part, also in this part, c is above x prime or x. In this part, x goes from minus infinity till minus radical 2 open. But in this part, x goes from radical 2 till plus infinity. So the solution of the inequality f of x greater than 0 is x belonging to the interval minus infinity minus radical 2 union radical 2 plus infinity. Of sure, open at minus radical 2 and also open at radical 2. Since f of minus radical 2 and f of radical 2 are equal both to 0, and I am solving it strictly positive. Now see, solve f of x greater than or equal to 0. There is a difference between C and B. In B, this inequality is verified when C is above x prime or x. But in C, I am saying greater than or equal to 0. So this inequality is well verified whenever C is above or intersect to x prime or x. Then the solution of f of x greater than or equal to 0 will occur in the case x belongs to the interval minus infinity minus radical 2. Of sure closed at minus radical 2. Since minus f of minus radical 2 equal to 0. Union the second part from radical 2 till plus infinity. Also we close the interval at radical 2 since f of radical 2 equal to 0. So the difference between in this inequality, the interval open at minus radical 2 also at radical 2, but in this inequality the interval closed at minus radical 2 and also we close the interval at radical 2. This is the difference between. Let us complete. D. Now solve f of x less than or equal to 0. This inequality is well verified whenever C is below or intersects x prime or x. Look at the figure. This is the region in which C is below x prime or x. So the inequality f of x less than or equal to 0 for x belonging to the closed interval minus radical 2 and radical 2. Now let us complete. 2 for what values of x C is below x prime or x. Look at the figure. It is very clear C is below x prime or x if x goes from minus radical 2, of sure open at minus radical 2, reaches to radical 2 also open at radical 2. Don't close the interval at minus radical 2 and at radical 2. Since f of minus radical 2 equal to f of radical 2 equal to 0. Let us complete. Application number 2. The graph C to the right is that of the function f in an orthonormal system. What is required? A. Solve f of x equal to 0. F of x equal to 0 when C intersect x prime or x. It is very clear that the solution of f of x equal to 0 or x equal to 0 or x equal to 3. Now B. Solve f of x positive. When we say positive, this inequality is well verified when C is above x prime or x, as we work in the previous slide. Look at the values of x. So x goes from 3 offshore, open at 3, reaches the value 3.49. Why I close the interval at 3.49? Since f of 3.49 equal to 3, which is positive, then 3.49 is included in the solution. But f of 3 equal to 0. This is why 3 is not included in the solution. Then the solution is the open interval at 3 and the closed interval at 3.49. Let us complete C. Solve f of x greater than or equal to 0. It is very clear the graphical meaning of this inequality specifies the possible values of x for which C is above and intersects to x prime or x. Look at the figure. In this case, the solution of this inequality is x belonging to the singleton of 0, union the closed interval 3.49. First of all, why 0 is included in the solution? Simply because f of 0 equal to 0. Why 3 is included? Also f of 3 equal to 0. Why 3.49 is also included in the solution? Since f of 3.49 equal to 3, which is positive. Let us complete D. Now df of x less than or equal to 0. Color the region in which f of x less than or equal to 0. It is very clear. This is the region in which C is below x prime or x. Then the solution of the inequality f of x less than or equal to 0 should be x belonging to the closed interval -1, 3. Offshore closed at -1 and at 3. Now, E. Solve f of x less than 0. In this case, take care. C is below x prime or x. Show the solution, the value of x equal to 0 is not included in the solution. This is why we say f of x negative for x belonging from -1 closed till 0 open, union from 0 open till 3 open also. Let us complete. Application number 3. C is the graph of the function f. It is drawn as shown in the orthonormal system. First of all, find df. Offshore, answer graphically the below questions. Since C is drawn over the interval -2, then the domain of definition equal closed interval -2, 2. Now show that 3 multiplied by f of -1 -2 multiplied by f of 2 plus f of 0 equal to 2. First of all, what is the value of f of -1? F of -1 equal to 2. What is the value of f of 2? This is x equal to 2. F of 2 also equal to 2. What is the value of f of 0? F of 0 equal to 0 since C passes through the origin. Replace each one by its value, we will get the final answer equal to 2. 3. Set up the table of variations of f over df. As we said before, table of variation defines the sense of variation of f. Look at the figure. Look at the figure. Over the interval -2 -1, it is very clear that f increases. First of all, f changes its sense of variation twice. The first time at x equal to -1, and the second time at x equal to 1. If x less than -1, it is very clear f is increases. If x between -1 and 1, f decreases. If x greater than 1, or x belonging to the interval 1, 2, f is an increasing function. Let us set up the table of variation. The table of variation is composed of two parts. The first part for x, the second part for its image. First of all, start by the domain. The first value of x -2 and the last value of x equal to 2. Don't forget, f changes its sense of variation twice, the first time at -1 and the second time at 1. So these two values must be considered in the table. Now over the interval -2 -1, it is very clear, this is the interval -2 -1. It is very clear that f increases. Increases from which value? From the value -2 reaches to this point, i.e. it reaches the value 2. Over the interval -1 1, it is very clear f decreases. Decreases from which value? It decreases from the value 2 reaching to this point, i.e. the value of f of x equal to -2. And now over the interval 1, 2, f of x increases from -2, reaches to the value 2. This is why the end value here is 2. This is a table of variation of f over domain of definition. Now let us complete part 4. For what values of x c is below x prime or x? I will try to color the region in which c is below x prime or x. C is below x prime or x over this region. Also C is below x prime or x over this region. So we say that C is below x prime or x for x belonging from -2 closed till minus radical 2 open, or from 0 open till radical 3. Why we close the interval at -2? Simply because f of -2 equal to -2, which is negative. This is why we should close the interval at -2. Now 5. Solve f of x equal to 0. It is very clear. The intersection between c and x prime or x occurs 3 times, at x equal minus radical 3, also at x equal to 0, and at x equal to radical 3. Then f of x equal to 0 for the values of x minus radical 3, or x equal to 0, or x equal to radical 3. Now let us complete 6. Solve the inequality A, f of x less than 0, B, f of x greater than or equal to 0. Let us complete. F of x less than 0. This will occur if c is below. So x belonging from -2 closed till minus radical 3. In this case, we open at minus radical 3. also from 0 till radical 3, which is open in both at 0 and radical 3. Now 6b, solve f of x greater than or equal to 0. This inequality is well verified whenever c is above x prime or x in this region and also in this region. So x should belonging to minus radical 3 closed till 0 closed, or from radical 3 till 2 closed. Let us complete. Now application number 4. The adjacent figure represents C, the graph of the function f, as shown in the figure. What is required is to find f of minus 2. F of minus 2 equal to 0. For f of minus 1, f of minus 1 equal to 4. F of 2, it is very clear, f of 2 equal also 4. Now, set up the table of variation over the interval minus 2, 2. As we said before, table of variation is composed of two parts, one of them for x and the other for f of x. Look at the interval minus 2, 2. F of x changes its sense of variation twice, one at this point and the other one at this point. So we put minus 1 and 1. Over the interval minus 2 minus 1, f increases from 0 to a value 4. Now over the interval minus 1 1, f decreases from 4 to a value 0. Over the interval 1 2, f increases from this value, which is 0, to this value, which is 4. And now 3, solve graphically f of x equal to 0. It is very clear. F of x equal to 0 for x equal to minus 2 or x equal to 1. Now, solve f of x less than 0. F of x less than 0 is well verified when c is below x prime or x. Look at the figure. Over which interval c is below x prime or x. In this region, c is below x prime or x. Then x goes from minus infinity till minus 2. Offshore open at minus 2. Since f of minus 2 equal to 0, but I am solving it less than 0. Let us complete. Now solve f of x greater than or equal to 0. F of x greater than or equal to 0, as we mentioned before, it is well verified whenever c is above or intersect x prime or x. Now look at the figure. It is very clear. In this part, c is above. In this part, also c is above. In this part, also c is above. At x equal minus 2, there is an intersection. Also at x equal to 1, there is an intersection. Consequently, the solution of f of x greater than or equal to 0 is x belonging from minus 2 closed till plus infinity. Also in this part, f is above x prime or x. Thanks for your listening.